Very good morning to all my dear students, and I'm back today with one of the most interesting concepts from the chapter Structure of the Atoms. As you all are aware, we have been learning about the various models which were put forward by different scientists actually in order to explain or elucidate the structure of atoms. There were so many atoms, and it was like a big challenge for the scientist to elucidate the structure of atoms, which is so very minute that cannot be seen with the naked eye. So this atom, the minute atom structure, it was like a really big challenge and task for the scientists to explain about its structure. So as you know, that J.J. Thomson or Goldstein and the Chadwick, these three are the scientists who discovered the presence of subatomic particles inside this atom. So by looking at the works, by going through the works of all these scientists, Rutherford or Goldstein or Thomson. So now Niels Bohr, actually in the year 1913, after going through all their works and all, he finally postulated his own model of atoms, which was very much accepted, and till it is like, when compared to the other models, it is more advanced form of model which could actually give explanations to the shortcomings or limitations of the models which were associated with the other models which were elucidated or postulated before this model. So just before this, we learnt about the Rutherford's model of atom. In that, we learned that everything was going on well, but he could not. There was a major drawback associated with his model, and that is, according to the electromagnetic theory, if any charged particle, if it is under acceleration, if it is accelerating, then it should continuously radiate energy. And Rutherford's model could not explain this, could not explain why electrons are not ultimately losing all the energy, radiating all the energy, and why are they not collapsing into the nucleus, and why is the atom more stable. Actually, if that is the case, the electron should collapse into the nucleus and the whole atom should collapse, and but we know that atoms are very stable, and how is it? He could not explain. In order to explain that, Niels Bohr, he is actually a Danish physicist, and he came forward with this structure of atoms. He contributed a lot towards the structure of atoms. In future there were some changes made to this Bohr's atomic model, and it's widely accepted. Let us see what are the main postulates which come under this Bohr's model of atom. You see that all these points, most of the points are equally the same as that of the Rutherford's model. You see here the atom consists of a small nucleus, which was told by Rutherford. Like he said that all the matter, whatever the mass is concentrated at the center, the nucleus is very small actually, and most of the space is empty. This is what he told. The same point even he acknowledged, like the atom consists of a small nucleus at the center. We know that in the nucleus we have, what do we have in the nucleus? We have protons and neutrons, and because of the presence of the protons, the nucleus gets the positive charge. The whole mass of the atom is concentrated at the nucleus. Why is it so? Because the mass is mainly due to the atomic mass. We have learnt in our previous videos, in our previous classes, that atomic mass is mainly due to the presence of protons and neutrons. The mass of the electron is very negligible, so we can't take it into consideration. The mass is mainly due to the presence of protons and neutrons, and those are present in the nucleus itself. So that's why the whole mass of an atom is concentrated at the nucleus, and the volume of the nucleus, if you compare the volume of the nucleus to the volume of the atom, you will see that it will be in the ratio 1:10 to the power of 5. Here it's very important to mention over here, 1:10 to the power of 5 indicates that actually the volume of the nucleus is about 10 to the power of minus 15 meters, and the volume of the atom is 10 to the power of minus 10 meters. So the difference, actually the ratio, can be given as 1:10 to the power of 5, children. Okay. 10 to the power of minus 15 is the volume of the nucleus, and 10 to the power of minus 10 is the volume of the atom as a whole. So here it is very clear that the nucleus is very small in size when compared to the whole atom. all the protons and neutrons are contained in the nucleus. That's what we learned, and that is why we see that the nucleus is positively charged, and also though both protons and neutrons they contribute to the atomic mass of that particular atom. Now from here there is a slight change, and actually this is what sets the Bohr's model apart, outstanding, because of these postulates. Please listen very carefully, children. Here also, I think Rutherford also told that electrons revolve around the nucleus, but he did not mention where they actually move. The electrons revolve around the nucleus in discrete energy levels, children. This is the difference. So Rutherford just simply said that they will be revolving around the nucleus. But Bohr actually mentioned particularly that they won't just revolve. It's not just as small as any other path, or it's not just any other orbit, but each orbit is nothing but it is associated with some amount of energy. So he called those discrete energy levels. So the name itself indicates here energy levels. That means each orbit or the path is associated with some amount of energy, and he named them as orbits or shells. Okay, so electrons, they will be revolving around the nucleus in definite circular paths which are associated with certain amount of energy. So as now you know that as long as electrons revolve or stay in a particular shell, say for example in the first shell, okay, if the electron is moving, as long as it is revolving in the first shell, it will not radiate energy, and this overcomes the problem or the drawback that was that could not be explained by Rutherford. So as long as now the electrons are charged particles, if they are there in a particular orbit, they will not lose or radiate energy. So they won't collapse into the nucleus. That's why the atom is stable. So here, like you see, to talk more about this, actually the energy levels are they are named, designated as 1, 2, 3 from the inside of the atom to the outside. Actually from near to the orbit which is near or closest to the nucleus is given the name as, like, they are designated as 1, and then the next one as 2, 3, so on. Or the first shell is designated as K. It is also denoted as K, L, second shell L, M, N, and so on. So you can see as the size of the atom increases, the number of shells also increase. Hydrogen, for example, hydrogen has only one electron, and that is it is present in the first shell only. It has only K shell, or it has only one shell. If you talk about sodium, its atomic number is 11. That means it has a third shell also. Okay, like 2 electrons in the first shell. We know, we have seen this already, right? 8 electrons in the L shell and 1 electron in the M shell. So like that, as the number of electrons increase, they just try and start entering into newer shells. So they are designated as 1, 2, 3, 4 and KLMN, etc. And the orbit which is nearest to the nucleus will have minimum energy, and the orbit which is farthest from the nucleus will have higher amount of energy. So as long as an electron stays in a particular energy level or orbit, it will neither lose energy nor absorb energy. But if an electron jumps from one electron from the nearest from one lower energy level to the higher energy level, so this is called lower energy level, this is higher energy level. Whenever it jumps from the lower energy level to the higher energy level, it absorbs some amount of energy. And the reverse happens when electron jumps from higher orbit to the lower orbit. When this happens, energy is released. Actually, there is a difference in the energies when an electron jumps from one orbit to the other. Okay. Each orbit is associated with certain amount of energy. This is what makes them to be called as energy levels, children. Okay. So this was about the Bohr's atomic theory, and there is a scheme which is called as Bohr-Bury scheme. This can be asked in the examination, children. What is the Bohr-Bury scheme? It gives you an idea of the arrangement of electrons in a particular orbit. So for any given For any given orbit or shell, the maximum number of electrons that can be accommodated in a particular or given shell is given by the formula 2n square. And Bohr and Bury, both the scientists actually gave this scheme. They said that maximum number of electrons which can be present in a particular shell can be given by the formula, we can get by the formula 2n square, where n is the number of the energy level or the orbit. Say for example the first orbit. So n becomes 1 for the first orbit, n becomes 2 for the second orbit or shell, n becomes 3 for the third shell, and so on. So you can see that for the first shell, how many electrons can be in the first shell now? 2n square, that means 2 into 1 square, which is nothing but 2 again. So 2 electrons, maximum 2 electrons can be present in the first shell. Now you tell me how many electrons can be present in the second shell. In place of n you have to write 2. 2 square, 2 square is nothing but 4. 2 into 4, 8. In the second shell we can have a maximum number of how many electrons can we have in the second shell? Maximum of 8 electrons only. After that, any other electron is there, it will go to the third shell. So we have already seen this. We have seen the dot representations. We got a fair idea of the electronic configurations too. So this was about the structure of atoms, children. I have already given you the notes. Please go through it and prepare nice. I want all these points to be covered. If you have not written from that, please copy down these points from this video and prepare this, because it is going to be asked. Maybe it may be asked for 5 marks or 1 marks or 2 marks questions in those questions. Okay, and there's one more topic left which I'll be just posting soon, which is about isotopes and isobars. Okay, please go through. That would be the last topic from this lesson and from the syllabus. Please learn the answers, learn the question answers, and go through the textbook well, children. Please prepare seriously for the PA4. Thank you.